going to talk about two topics which are currently central topics in my research and my collaboration with industry, which are digital twins and artificial intelligence in supply chain management. Right. So yeah, to introduce myself, I'm Dmitry, professor for supply chain and operations management at Berlin School of Economics and Law, which is a public business management university in Berlin, in Germany, the capital of Germany. We have about 12,000 students. And at this school, I am director of a digital AI supply chain lab, which is currently involved in several European projects about digital twin resilience of supply chain. And we also got some major funding from a German Research Foundation and some funding from university. So it's quite a growing lab with several young, motivated researchers who are also interested in this topic, digital twins and AI in supply chain management. All right, so let us start. I would like to talk about four major topics today. The first is digital supply chain twin and why we need now a rebooting of supply chain simulation. The second topic will be about digital twins of supply chain. Then, in order to illustrate theoretical concepts and to explain, say, in my opinion, the most advanced technology which we currently have for building digital supply chain twins, anyLogistix software, I would like to show some application examples for resilience management. And finally, my idea is to try to predict future, because I mean there is also always a gap between what happens in research and what happens in industry. Usually this gap, it's like several years, 5 to 10 years. So essentially, what happens in research now, we will see in industry in several years. And that's why I would like just to talk to you about current projects and movement toward intelligent digital twins and human AI interfaces. Yeah, and here you see some books if you are interested to learn more about these topics. Here you have some references and a very new book, this one which appeared just today. So today I have to celebrate not only my talk at anyLogistix conference, but also appearance of the next book, which is Introduction to Supply Chain Analytics with examples in anyLogic and anyLogistix software. So both theory and hands-on exercises. Okay. So let us begin, and yeah, let us begin in general with the understanding, right? So simulation is something what it's used to imitate behavior of one system with another, and by making changes to the simulated supply chain, one expects to gain understanding of the dynamics of the physical supply chain. So in contrast to analytical models where we usually derive some mathematical solution to a problem, in simulation we rather experiment with the model, and we do it by making changes in the input parameters of the system and observe outcomes, differences, commonalities, randomness in outcomes through running different experiments. There are many approaches to run simulations. 3 of them are depicted on this slide: system dynamics, agent-based simulation, and discrete event simulation. Right. So system dynamic is something what we use in supply chain management specifically for studying rather strategic level problems, right? Like market level, network level problems where we actually look at causal dependencies between different interrelations between different parameters. Agent-based simulation, it's a useful tool where, especially currently in the times of growing interest in AI, agent-based simulation, it's used to, to mimic behavior, behavioral aspects and decision-making rules associated with humans. Finally, we have discrete event simulation, last but not least. So discrete event simulation is probably the most popular tool used in supply chain operations management. Where different processes are described as event chains and modeled using queuing theory, the different elements of which are implemented in discrete event simulation. So normally, these three methods are used. Also, combinations of these methods, like, for example, discrete event simulation with agent-based simulation. So simulation, supply chain simulation has been here for a while. It is not something new. At the same time, the developments of recent years have opened new opportunities, challenges, and advantages for supply chain for building supply chain simulation models. So when you develop a supply chain simulation model, even if you have full availability, say, of historical data, there are always some questions, right? Real-time data, accuracy of data, system visibility, right? What scope of system I can observe, like in supply chain? Can I observe only my own manufacturing companies, or can I observe, say, first and second tier suppliers? Data analytics, right? So we have different types of analytics: descriptive, predictive, prescriptive analytics. So now we can do a lot with data, right? And finally, decision-making support, right? So it is a big difference if we just have one model or if we have decision support system. So, and this is essentially the questions which I would like to focus on during our discussion today, or during my presentation today. So how we can represent the physical supply chains in the best way in digital models, and how we can make the best use of this data using supply chain analytics. All right, so now let us turn to digital supply chain twins. I was fortunate to be involved, and I am still fortunate to be involved in different projects, research projects, industry projects for building digital supply chain twins. Reflecting on this project, I think we should start with the fundamental question: what is a digital supply chain twin? Right? When talking to industry experts, to industry leaders, and to my colleagues in research, I think there is no consensus about it, right? So different colleagues understand digital twins in different way, right? So for some colleagues, it is enough to collect data in one place, like in a cloud, data about supply chain, and then they already think it is a digital twin. Some colleagues think beyond of this and look toward an active usage of data. So analytics, and even building digital decision support systems, right? So essentially, I think when we try to combine all different views on this topic, it looks like digital twin should comprise at least three major elements. The first element is digital visualization. So virtual representation of a physical object. In our case, in anyLogistix, we built a digital supply chain model showing firms, flows, planning and control algorithms associated with operating supply chains. But it's not enough, right? Second, we have to get data into this model. And that's why the second element is the digital technology. Digital technology. So the first element, it's virtual representation. The second is digital technologies. How can we get data into the digital twin, right? It can be Internet of Things, blockchain, different sensors, cloud data, ERP systems, and other types of systems, TMS, and so on. But even this, it's not the end of the story. Okay, now we have model, we have data. And here the third element comes, analytics. Now we need a tool which is able to do something with data, right? So descriptive, predictive, and prescriptive analytics. So performance visualization, simulation, predictive analytics, and optimization as prescriptive analytics. So when we have a combination of all these three elements, we can say, yeah, so we have built a digital supply chain. This was the first fundamental question which is frequently asked: what is a digital supply chain twin? The second fundamental question which is frequently asked, it's what is the difference between standalone simulation model and a digital twin? I think there are at least four major differences. First of all, digital twin is supported by real-time technology, which implements data collection, processing, visualization, and generation. Right. Second, a digital twin, it is not just one model. There's a combination of different models: optimization, simulation, visualization. Third, digital twin includes not only internal data, but also pre and post processing of data in integration with external systems, like data from ERP systems, which are pre-processed and transferred to simulation, to optimization model, and also results of simulation and optimization are post-processed in other tools in external systems. So digital twin, it is not just one software. Digital twin, it's a combination of different IT systems. And finally, last but not least, and very important, I would like to stress it particularly, digital twin, it's knowledge-driven, knowledge transferring and knowledge creating system using human-machine interface. So knowledge, it's a key word when we talk about digital twins. Yeah. One important part of digital twins are supply chain analytics. Right? We usually have different types of analytics. Major are descriptive, predictive, prescriptive, and monitoring. So descriptive analytics are used for performance visualization. For example, if you as a supply chain manager have a question, how was my on-time delivery performance last year? You take historical data, you visualize them in a nice way, and yeah, then you can answer this question. Then maybe you are interested not only in the retrospective analysis, but also you want to look into the future. So you say, okay, I want to predict I want to make a stress test, right? How resilient is my supply chain performance to a supply disruption? So this is a case for simulation analysis. Okay, so you have predicted something, but you don't know what to do in case of particular scenarios. And here we have prescriptive analytics. What can we do to improve our on-time delivery performance next year? And this is something what you can answer with the help of planning, with the help of optimization. And finally, since we talk about real-time data, I mean, as a supply chain manager, you can be interested just to understand what are our inventory and lead times right now. So availability of real-time data in digital twin helps you to do this monitoring and understand real-time situations. Okay. anyLogistix, it's a tool which you can use for building digital supply chain plans. Essentially, in anyLogistix, first of all, you begin with creating virtual representations, digital model of a supply chain. Right, in anyLogistix, you first of all describe your customers, your production sites, distribution centers, suppliers, transportation routes, products which are operated in the supply chain, demand of your customers. And with that, you more or less create a model of your physical supply chain where you have firms, you have flows, right? The second step is to get data into the supply chain, right? And once you into the digital model of supply chain, and once you got the data, you can start using them. Analytics, network optimization, simulations, performance analysis. You can also run resilience analysis, risk assessment to understand recovery time, to make some stress testing of your supply chain. Yeah, so this is essentially the logic of how to build digital twins using anyLogistix supply chain simulation and optimization software. And let me illustrate example of using digital twins built with the help of anyLogistix in one very important area, which is supply chain stress testing. You know, currently resilience became key topic, most important topic on the agenda of industry and research. Supply chain stress testing is something what is of high interest for industry and for academia. So the principal mechanism of stress testing you can see on this slide. It has three major components, which are risk data, supply chain model, and performance analysis. So it begins with building digital supply chain model, where you essentially map your physical supply chain. You show where your distribution centers, what are your customers, where are your factory centers. Then you develop a sort of external system for risk analysis, monitoring, and alerts. Right? There are many such systems in the market. I will not focus on any particular systems. So essentially, all these systems are using text mining technologies. They are searching through huge number of texts in newspapers, in social media, in all available sources to identify disruptions, right? Then once disruption is identified, it is mapped with supply chain locations. If we see, okay, in this particular area, we have our supply chain facilities, then this disruption is important, right? And then we make stress tests, we run simulation models to understand performance impact of this disruption, right? So make according to different KPIs like on-time delivery, like fill rate, like sales, like time to recover, time to survive, you know, all these KPIs used for resilience assessment. And so in this way, we make stress test of supply chain. Yeah, this is essentially how it works. You can do it in a proactive way using historical data, so data from past disruptions. Or if you face real-time disruption, okay, so then you take the path where you make recovery plan selection and assess real performance impact of a disruption on the supply chain. Good. So this is the application example. And finally, as I promised you, I would like to spend some minutes talking about future developments. So far we have talked about digital twin, which I named digital twin of the first level. Digital twins which have virtual computer model of a real object and optimization, simulation, forecasting algorithms. So then we have the second level. So this is the first level. The second level, it is something what we name cognitive digital twin. So digital twin equipped with some AI capabilities. But these AI capabilities only mimic, only replicate human knowledge. For example, if in my company, we already had experience at one supplier, I can put some policies, some decision-making rules into my digital twin. And if we would encounter this, I would say, standard situation again, then, I mean, even an unexperienced manager in my company could get suggestion from a digital twin how to handle this situation. But again, it works only if we encounter standard situation, something what we already had in the past. And in order to generate new knowledge, we develop intelligent digital twin, or as we say, digital twin of the third level. So all this is explained in my paper, which you can see here. If you want to read more, please go to this paper. Yeah, essentially the third level of digital twin, it's responsible for knowledge creation, right? It does not only mimic decision-making rules designed by humans, but it creates new knowledge and new decision-making algorithms through self-learning and human AI collaboration. So in other words, this intelligent digital twin helps to understand the system better, helps me as supply chain manager to understand my supply chain better. And in some cases, it can even take over some portion of decision-making, especially if we talk about some routine, some standard decisions, right? Okay, so this is the idea of intelligent digital twins, and this is what my team is now researching with different industry and academic partners. Yeah, that's why I would say simulation is definitely a driver of future decision-making systems. The current state is that we have that companies have data from different transactional and management systems. And many companies already integrated this data in some cyberspaces, clouds, and so on. So that's why I would say this first step, data-driven technology, it's already more or less a standard state of the art at industrial companies. Many companies already moved towards data-driven organization, where they integrate data. So after data was collected, they integrate data in clouds, using blockchains, different collaborative platforms, Internet of Things. And currently, the next step, which will be done in the next years, it's a transition from data-driven organization to digital management system and decision-making. So the transition means that now, after all data it's integrated, we should start using this data with the help of analytics, simulation optimization, performance management, process mining, and AI, generative AI metaverse. So this is the step which we expect in the next years, and also which the companies I'm working with also discuss currently as the next step for transition from data integration to real data analytics. So that, yeah, we have digital management system and decision making support. Yeah. Good. So I think that was a major part I wanted to discuss with you, right? So yeah, we are very happy to participate in several projects, research projects. Some of them you can see on the slide. It is, first of all, the Accurate project made in Europe, digital twins, manufacturing as a service, so achieving resilience through manufacturing as a service, digital twins and ecosystems. Then another project focusing on agricultural supply chains, which will start in 2 days, on June 1st. On June 1st, we start the Prima project, Cereals Resilience Revolution for Agile Supply Chain Management in the Mediterranean. And very, very large project, Collaborative Research Center, Resilience of Global Supply Chain, which began this year and for 5 years, where many professors from Berlin School of Economics and Law are involved to research resilience from very different perspectives. All right. Yeah. Thanks for your attention. So essentially, summary of my talk. It's very simple. I believe that simulation is a key methodology and technology for digital supply chain twins. Digital twin is a multi-dimensional concept comprising models, data, interoperability, and knowledge. With anyLogistix, we are lucky to have a powerful decision support system covering all components for building digital supply chain twins. And all components mean you have digital supply chain mapping, you have data, you have interoperability, you have descriptive, predictive, and prescriptive analytics. So digital twins can enable end-to-end supply chain visibility, so which is of great value for managing supply chain, both at normal times, if we, I don't know what you can now name as normal, but if there are normal times, then at normal time, but also at crisis times. So currently it looks like all times are crisis times, right? But let us hope for the best. And in future, I would say I would expect more AI integration and human AI collaboration in digital twins. So if I can give an advice to my colleagues who are developing anyLogistix, I would say the research community and industry community would really appreciate if you would integrate some AI components or human AI collaboration components into anyLogistix, right? Then it would really make it, as I presented, digital twin of the third level. Now we are on the digital twin of the first level, but integrating AI components, we can get to the second level. And when we reach human AI collaboration, then we get third level of digital twins. So yeah, these are the future areas to transit from offline modeling to data-driven digital twins, enhance human AI collaboration. And essentially, we all want to understand the role and value of real-time data for decision-making, how a future supply chain manager will take decision. So I am director of Master Program Global Supply Chain Operations Management here in Berlin. Each year we get 40 young, motivated, talented future supply chain managers, and we all really want to understand what knowledge we should equip, with what knowledge we should equip these young people so that they can be competitive in the market, in supply chain management market. And for that, we should understand how decisions will be done in, say, in 5-10 years in real life. My sentiment is that will be human AI collaboration, but how it will look like, it is topic of another talk. For this talk, thank you very much for your attention. And if we have time, I'm happy to answer some of your questions. Yes, thank you for your attention. Yeah, basically some questions I see are about how to integrate anyLogistix and anyLogic into building digital twins. Yeah, essentially, I think both software play a key role in building digital supply chain twins. With anyLogistix, I would recommend to look at supply chain level, where we talk about network optimization, where we talk about resilience analysis, we talk about inventory simulation, and everything related with flows between the companies. And when we talk about internal flows, which are inside of company, like in a warehouse, in manufacturing, in logistics, in the company, then it is better to use anyLogic. Right? Of course, you can build supply chain models with anyLogic too, but it can be more time consuming. Okay, you can build more, I would say, customized models, right, with anyLogic, because in anyLogistix, you already have some standardized pre-programmed models, which of course you can change to some extent, but not to full extent. Right? So in any logic, you can write a model from scratch. But in my opinion, it's better suited for, say, manufacturing, internal logistics, warehousing, and for supply chain. anyLogistix is actually can be used because it covers 99% of typical industry practices is used in any logistics. Yeah, then I think there are some questions about research, like what are the current topics in digital twins in AIs. I published some papers on this, and many of them are actually yes, I actually put into this presentation, so you will receive slides. You can see some references. You can also go to my website, or you can go to to my website, which you can see here, and you can also go to Google Scholar, for example. So, but I will also respond to suggestions, some references, not only my papers, of course, but other papers.